Yeah, uh, okay. Welcome to lecture number. I don't remember the lecture number exact, but most probably it is 24. Most probably, okay. So now we will do a 2018 year PYQ in this class. Okay. Which of the following functions? Which of the following functions? Okay. Is are acceptable solutions of the Schrodinger equation. Which of the following functions is are acceptable solutions of Schrodinger equation? So, what does this mean actually? This actually means that the wave function which will be realistic. Okay. So let me write over here. You have to basically find out the wave functions. Okay. The wave functions which will be realistic will be acceptable will be acceptable solutions of the Schrodinger. Okay, so the wave functions which will be realistic will be acceptable solution of the Schrodinger equation. Okay. So number one which you have to determine is psi x is equal to a e to the power minus I kx plus b e to the power I kx. Okay. Then second function is psi x is equal to a e to the power minus kx plus b e to the power kx. Okay, this is the second function. Psi x, this is the third function which has to be determined. A sine 3kx plus b sine 5kx. Number fourth which has to be determined is whether it will be realistic or not. If it is realistic, then obviously it will be acceptable solution of Schrodinger wave equation. Okay, so this is the question which had been asked for 15 marks in the year 2018. Okay, so and it was also written at the end that explain your answer. Okay, which was quite obvious. Okay, explain your answer. It was written at the end, which is quite obvious. Okay, so answer. Now answer will be very obvious. So we can write as extension. Okay, as extension of space is as extension of space is not defined. Clearly over here the extension of space is not defined, right? Whether it will be in certain volume or like that, nothing has been defined. Okay, so as extension of space is not defined, so we will take So we will take minus infinity to as the limit. Okay. So we will take this as the limit. This I have already explained in the preceding classes. Okay. Already explained in preceding classes. Okay. Already explained in preceding classes. I had already explained that if all space is not defined, then we take then we take all space as minus infinity to plus infinity. So this has already been explained in the previous classes. Now, number one question, how we will solve. In the question number one, it has been given that psi x is equal to a e to the power minus I kx, okay, plus b e to the power I kx, okay. It has been given. So clearly from here one can say that psi of x is oscillatory, and how it is oscillatory, this will be dealt, okay. If you complete the course, then you will come to know that psi of x is oscillatory. This expression is oscillatory, you will come to know if you complete the course, or else if you have learnt it already, then you must know that it is oscillatory, so it remains finite, okay. So it remains finite everywhere. So it remains finite everywhere for all values of x, okay, for all x. Psi x, okay, psi x and del psi x by del x, okay, are also continuous, are also continuous and single valued, okay. It is quite obvious because when you will expand this, you will basically use the Euler's formula, okay. I hope it is called as Euler's formula only, right? E to the power I theta is equal to cos theta plus I sin theta. It is called as Euler's formula only, right? So psi x and del psi x by del x are also basically continuous, okay, are also continuous and are single valued, okay, and are single single valued, okay. So it is acceptable solution of, so it is an, so it is an acceptable solution of Schrodinger equation as seen, as seen in case of step potential, barrier potential, etc. This you will learn in the upcoming classes. I am giving you a ready-made answer, okay. I am giving you a ready-made answer. This will be ultimately dealt in the upcoming classes, okay. This will be ultimately dealt in the upcoming classes. Now the second the wave function which has been given to us is this, okay, a e to the power minus kx. Don't worry if you didn't understand the first one, okay, it will be covered in the upcoming classes, all these things, okay. It was the part of the same question, that's why I wrote its solution. Otherwise I haven't taught you this yet. I haven't taught you all of this yet, okay. I have not taught you, okay. Up to here only you will understand it, Up to here only you will understand. But after this, whatever is written, so it is an acceptable solution of Schrodinger equation, and these all these things. This you will understand only after, and this also you will understand only after you complete the course. Psi x is oscillatory. This you will understand only after completion of the course. So keep watching it till the end. If you keep watching it till the end, then it will be uh, beneficial to you and you will be able to do it. Okay. So the second function which has been given to us is this. Now if x is equal to infinity, then psi x, okay, is equal to a e to the power minus infinity. It is very clear from the formula above. Okay. So clearly this will turn to 0, this will turn to infinity, and it will be infinity in turn. Okay. And if x is equal to minus infinity, then what will happen? Then psi x, okay, is equal to a e to the power infinity plus b e to the, we are basically substituting the values and we have done nothing. We have basically substituted the values. Okay. So we have substituted all these values. Okay. We have substituted over here in the place of x all these values, infinity minus infinity, we have substituted and we have obtained this. Okay. Thus we come to know, okay, thus psi x is not equal to finite at x is equal to plus minus infinite. Okay. So so it is not an acceptable solution. I had already told you in these previous classes, in the previous classes this has already been told that how the function becomes acceptable and how it becomes non-acceptable. Okay. So these things have already been told to you. Okay. So it is not an acceptable solution, okay, of Schrodinger equation, right? So it is not finite, it must be what does the condition number 1 say, which we have already covered in the previous classes. The condition number 1 says that for every value of x, for every value of x includes minus infinity and plus infinity, for every value of x it must be finite. Okay. Psi of x and del psi by del x, they should be finite for every value of x including plus minus infinity. But over here finite value is not coming. We are getting undefined value, so not finite. So that's why it is not an acceptable solution of Schrodinger equation. Okay. So this is the thing. Now the third point. Now the third point is third wave equation which has been given to us is again uh, like this: a sine 3kx plus b sine 5kx. Okay. So how will you find its solution? So clearly psi of x is your oscillatory. Okay. Again you will learn this oscillatory thing. If you don't understand this thing, then don't worry. If you don't understand this thing, then don't worry, I have not covered it yet. I haven't covered it yet, but I will cover it in the upcoming classes. Okay. So don't worry if you don't understand certain things. Okay. For all values of x continuous and single valued. Yeah. this will be your acceptable solution. What does this imply? That it is acceptable solution. Now someone says that psi x square, haven't we find the square integrability condition? Haven't we find the square integrability condition? But it is quite obvious that it will satisfy square integrability condition. You must write over here that also. But the thing is that if we have written that psi of x is oscillatory, then we need not write that it is square integrable. Okay, it is quite obvious from this thing in the box. From this thing in the box, it is quite obvious that it will be square integrable as it is oscillatory function. Okay, so no need to write that separately. Okay, now the fourth function which has been given to us, which has to be determined whether it will be a valid wave function or not. The fourth thing which has been given to us, okay, consider this as 4. Okay, so it has been given that psi x equal to a 10 kx. Okay, it is given like this, right? You must have written in your notebook. Now you can see this clearly that 10 kx varies between, okay, 10 kx varies between minus infinity and plus infinity. 10 kx varies between minus infinity and plus infinity. It is a discontinuous function. Okay, it is a discontinuous function. Okay, so clearly it is a discontinuous function. Why it is discontinuous? Because when you will draw its graph will look something like this. Okay, its graph is going to look something like this. That suppose you have this thing. Okay, and suppose it is like this. Okay, so clearly at these points it is discontinuous, right? Because I had told you the informal definition of continuous and discontinuous. I had told you that the function which can be drawn without raising the hand, function which could be drawn without raising the hand are called as, मतलब जिनको हाथ पेन बिना उठाए बनाया जा सकता है, पेन को पेपर पर से बिना उठाए बनाया जा सकता है, मीन्स those which can be drawn without raising the pen upward from the paper, those functions are called continuous functions. Now clearly, even if you try to draw it without raising the hand, you will be able to draw this much only. Okay, you cannot draw the whole curve, so it is clearly discontinuous function. But what happens in case of sin x and cos x? In case of sin x and cos x, you can draw it without raising the hand. Okay, without raising the hand you can draw it, without raising the pen you can draw it. Okay, without raising pen you can draw it, right? But over here, when you draw here, then the next curve can't be drawn by you unless you lift the pen. Okay, suppose you were drawing and you drew up to here, suppose. Okay, you drew up to here, then the next when you will have to draw the next thing, that will be from downwards. Okay, so you will have to lift your pen. Okay, you will have to lift your pen. So that's the thing. So it is clearly a discontinuous function as it is abruptly changing from plus infinity to minus infinity at this particular point pi by 2. Okay, okay, so it is clearly a discontinuous function. So clearly we can say one thing over here, that and in the exam you have to draw the graph also. Okay, in exam you have to draw the graph also. So you can write over here that as it is discontinuous, so not an acceptable, not an acceptable solution of Schrodinger equation. So it is not an acceptable solution of Schrodinger equation. So thank you very much. Jai Hind, Jai Bharat. अपना ख्याल रखें. And Telegram, if you haven't joined, then you should join it. Okay.